What is a skip entry, and how does it differ from the lifting and the ballistic entries? Here we have our spacecraft coming back to Earth, now coming through the atmosphere. Now this spacecraft is totally symmetrical, which means it's exactly the same in every way either side of this line. So we have to the right or to the bottom the heat shield, and to the left the main body. Now here we can see its direction of motion. Its direction of motion is along its line of symmetry, which is quite interesting. You now have an aerodynamic resistive force, which is also opposite but in the same orientation as the direction of motion. And we define this force in this direction as its drag. Now what happens if we change the angle at which the spacecraft comes in at? Like this. We now rotate the spacecraft by a small angle towards its direction of motion, and we call it the angle alpha. Note, the aerodynamic resistive force is no longer in the direction of motion. So therefore, what we need to do is to break up this force into two components, a component which is perpendicular to its direction of motion and one which is parallel. The parallel one in green, that means it's in the same direction but equal and opposite directions, is called its drag, and that will just simply convert the kinetic energy into thermal energy. So it's going to slow it down, and then you have a force of lift. Now you will have some conversion into thermal energy, but what it does is it generates an acceleration in that direction. So what it's going to do, it's going to cause this spacecraft, as it falls along its direction of motion, to also accelerate, in this case, upwards and to the right. Now let's look at the three trajectories. Now the ballistic entry has no lift, and it comes relatively straight in. In fact, it still takes over 1,000 kilometers inside the atmosphere. The lifting entry, this is what the Apollo did. It does have an element of lift, but it remains within the upper atmosphere, but it extends both its time and its length of reentry. Now, the skip entry, such as by the Orion, skips back outside the atmosphere, not by much. There is lift. This greatly extends its distance, and whilst extending the time of reentry, we reduce the peak heating rates and structural stress on both the astronauts and spacecraft.